Hello, students, and welcome to another geometry lesson. Today, we're going to talk about two theorems of intersecting secants on a circle. So, what are you supposed to know? Well, there are two theorems of secants. Last time we talked about chords and tangents. Today, we're going to talk about the secants, right? There are two theorems. One is a segment theorem, and the other one is an angle theorem, just like before, like the tangents and the chords. They all have a segment theorem and an angle theorem. Well, what are secants? Secants are actually lines that go through the circle, unlike the tangents. The tangents only touch the circle on the outside, right, at one point. The secants actually go through them. So here you have secant CF and secant DF. When they go through the circle, of course, they intersect the circle at 2 points right here, a C and B for that secant 1, and then D and E for secant 2. So there are two, these points. These points are what we're going to be talking about when we talk about their theorems, right? So you have BF is the outside segment, EF is the outside segment, F is the common point that they meet, CB is the chord, DE is another chord, and then of course DF and then CF would be the secant segment, right? So you need to recognize what these are and know the definitions before you can use the theorems to apply them to problems. Okay, so let's talk about the first one. The first one have to do with segments relationships. Excuse me. So it says if two secants meet, the products of the lengths of one secant and their exterior parts equal to the other one. So that's what this is saying, right? So let's put that in mathematical context. You have one secant here, okay, from segment A and segment B make up this red secant. Segment C and segment D make up this purple secant, right? What this theorem is saying is if you take segment on the outside, so let's look at the red segment, right? That would be the secant one, segment one, right? The exterior part would be this segment right here, B. And if you multiply that by the whole entire secant, well, the whole entire secant would be A and B together, right? It would equal to the exactly the same thing on the other side or for the other segment. So if you take the outside segment, which is D, and you multiply by the whole entire secant 2, the second secant, C plus D, then that's their relationship. So this is, we're going to use simple to indicate this theorem, right? So if you take B, which is the outside segment, and you multiply by the whole thing, notice I'm not multiplying by the chord, I'm multiplying by the whole entire secant, and then that would equal to the other secant, the products of the outside times the whole thing, okay? So take a minute to observe, okay? So outside times the whole thing equal outside times the whole thing, okay? Let's look at this example. We need to find the value of x. The value of x is from O to G, right? So if you notice here, these are the secants right here. OL is one secant. SL is the other secant. And the outside segment for OL is GL, right? And then the whole entire thing would be OL, right? So the theorem says take the outside, multiply it by the whole thing. So take the outside, multiply by the whole thing. Well, the outside is GL, and the whole thing is OL. And then that would equal to the other segment. Take the outside, which is EL, and multiply by the whole thing, which is SL, right? So remember in geometry, the first thing you always put down is the relationship, right? You put the relationship down and then you use that relationship. You're going to substitute in what you know to come up with an equation. So what do we know? We need to know the segments, right? So segment one, the exterior segment one, we already know is GL. That would be 6, right? So we know that that's 6. Now the whole entire secant is not x, it's x and 6 together. Now x and 6 is x plus 6, not x times 6, okay? And means adding, right? So the whole entire secant for the first one, for OL, would be x plus 6, right? And we put that in parentheses because it's a whole quantity. And equal to secant 2. Well, the exterior segment of secant 2 would be EL. Well, EL we know is 8, right? And then we multiply that by the whole thing. The whole thing would be 18 plus 8, right? The whole thing would be 18 plus 8. That would give you 26. And then you just solve this equation, right? You distribute the 6, and then you multiply the 8 into 26. You subtract 36 on both sides to get 6x by itself. And then that would equal to 172, because 208 minus 36 is 172. Then you divide it by 6 to get an approximate answer of 28.6, repeating, or 28.7 if you're going to round that up, right? So that would be the value of the chord OG, okay, or the value of X. All right, let's take a look at another one here. Pretty similar to the one we just did. Find the value of X. X is also OG. Oh, they're using the same letter, I think. No, not really. Just the first segment. So we know the outside times the whole thing, right? The outside times the whole thing. The outside is 10 times the whole thing, which is X plus 10. And then on the other side, the outside would be 8 times the whole thing would be 8 plus 8, which is 16. And that's where that 16 comes from, right? And here's your equation. You're going to substitute, or not substitute, you're going to multiply the 10 through, okay? And multiply the 8 and the 16. This is all algebra, guys. Subtract the 100 and divide it by 10, and x would equal to 2.8. One more. Okay, very similar also. We're looking for the segment X as well. Okay, so we're looking for the inside segment. Oh, they're using the same letter, just different numbers. So here we go. The outside, which is 3, times the inside, which is X plus 3. And then the outside is 4 times the whole thing, which is 9 plus 4. So if you guys want to, pause this video, try this problem, and then continue to see if you get the answer you're supposed to get. Okay, so here's my equation. If I work this out, multiply the 3 through, multiply 4 and 13, subtract the 9, divided by 3. My answer is 14.3, repeating. Next theorem. This has to do with the angle. So it says if two, this is very similar to what you've seen before with the tangents, right? Uh, so, I mean, it's not different. If you have two tangents intersect, just remind yourself the outside angle is the average of the difference between the two arcs, right? So this is this is the same thing. If you have two secants intersecting, the outside angle is half, which is the average of the big arc minus the little arc, right? The difference between the two arcs, okay? So, and then divided by 2. So it is the exact same relationship, sort of say, right? It's a different theorem, but it's the exact same relationship. To find the outside angle, which is angle A, you take the big arc, which is DE, right? And you subtract the little arc, which is BC. I call it the outside arc and the inside arc, if you want to look at it that way, right? The outside arc or the big arc minus the little arc, because if you don't do that, you're going to get a negative answer. And then divide that by 2. Okay, so that's, I mean, you should be familiar with that relationship already, because we already talked about tangents. So here we go. We're looking for angle A, which is the outside angle. So it's the difference between the big arc and the little arc, and then divided by 2, right? So the difference between the big arc, which is DE, minus the little arc, which is BC, and then divide that by 2, or multiply by 1/2. It's the same thing. So you substitute it in, okay? You come up with the relationship, you substitute values in, and then you do some math to solve for angle A, right? So angle A happened to be 49 degrees. And that's it for today's lesson, guys. Thank you so much for watching, and be looking out for my next videos on some more geometry. You guys have a good day.